Let's go ahead and sort of revisit Fibonacci again. Now, Fibonacci was an Italian mathematician. So what I did was I went to one of these text-to-image AI generators and said, give me images of mathematicians. Give me images of people who were not very happy looking. You think about it, right? I mean, how do we sort of portray mathematicians in the sort of public eye? If you look at movies like The Beautiful Mind, which was about John Nash, you look at The Imitation Game, which was around Alan Turing, then mathematicians are certainly portrayed as people who do very useful things. But for one reason or another, they don't necessarily end up in very happy sort of circumstances. And I guess those kind of portrayals then sort of feed into AI-based systems as well. And so that was sort of an interesting thing that I tried. And here are some images that sort of came out. So that's one of the images that came out of one of the AI-based systems, is what a mathematician could look like. And the other one was slightly odder, but that's all right. I guess that's a portrayal of a mathematician as seen by an AI-based system. Okay, so let's actually get back to the sequence we were after, which was the Fibonacci sequence. Now recall that f of 0 was 0 and f of 1 was 1. And the relationship was fn is equal to fn minus 1 plus fn minus 2 for n greater than 1. And the key thing that we were really after was that if you wanted to compute the nth Fibonacci number, then as n got larger, f10, f100, f1000, then it was very clear that the computational burden would increase. So let's get to the task that we had actually set to ourselves. The task that we had set to ourselves was, can we design two algorithms for computing the nth Fibonacci number? Now, bear in mind that the definition remains the same, but how we decide to implement it, i.e. how we decide to create algorithms for computing the nth Fibonacci number, can change. So there does not have to be a unique way of doing it. And hence the question we had set for ourselves was, can we design two algorithms? And one of the questions I've got back was, can you offer a potential framework for working towards the first algorithm? Sure, let's try and do that. So when we're trying to work towards the first algorithm, try and break up the task into different components, right? Makes life much sort of easier. So the first part is write some pseudocode. Just go from the definition to pseudocode. Just do that. Task 1 done. Task 2, analyze the algorithm. We've talked a little bit about the sort of big O notation. Go ahead and analyze that algorithm. And the third is code it up. Code it up, play with it, experiment with it. And this process of writing the pseudocode, analyzing the algorithm, coding it up, and experimenting and playing with it will give a real feel of the algorithm. And as you do that, there's a decent chance that you will get some ideas on how to design the second algorithm. So I'll leave that with you for now, right? Try and follow the sort of three-stage process for the first algorithm, see how you go, and there's a very good chance that you'll start developing some ideas to how to get to the second algorithm.